Hello again, everyone. This is Mr. V. Hill, and today we'll be talking about functions again, but this time specifically about the domain and the range of a given function. And so just to review, a function we define to be a relation, meaning just a set of ordered pairs with an x-coordinate and a y-coordinate each, in which each input, meaning the x value, is paired with exactly one output. And the inputs are x, outputs are y, or if we're using the function notation, f of x, if the function is named f, or g of x, whatever. Now, specifically the domain and range of a function, here are the definitions of those. So the domain of a function is just the set of all possible inputs, or all of the x values. The range is a set of all outputs, the y's, or of course, f of x, g of x, whatever. And so what we need to be able to do is to identify the domain and the range of a given function given any of the 5 usual representations that we looked at last time in class. So we might look at a function as a set of ordered pairs, or a table, or a mapping diagram. These 3 are really just different versions of the exact same representation. But we might also look at a graph of the function, meaning the ordered pairs x, y as points in the coordinate plane, or even as just an equation. And so let's look at a couple of examples here. We'll start off with just the first 3 representations. And so example 1, we're looking at just a set of ordered pairs, like here. We have the ordered pair 2, 3, there's the x, there's the y. 7, 6, there's the x, there's the y. Negative 4 is an x and it's paired up with 2. And then we have smiley face, which is paired up with the y of rhombus. So, of course, usually we use numbers in here, but there's nothing in the definition that says they have to be. And so we can look at it as a set of ordered pairs here. Or if we write the ordered pairs vertically like this in a table, it's the exact same thing. 2 is matched up with 3, 7 with 6, negative 4 with 2, and smiley face with rhombus. Or putting it into a mapping diagram, notice we have all of the x values over here in the left-hand blob, and the f of x values, or the y's, over here in the right-hand blob. And the function itself, meaning the matching up, the pairing of the x with the y, is shown by the arrows. So again, 2 is matched up with 3, 7 is matched up with 6, negative 4 with 2, and smiley face with rhombus. And so in this case, it's pretty easy to write the domain and the range here. It's a discrete set of values, so all we have to do is just say, well, the domain is the set of, and remember we use these brackets these braces, excuse me, to denote a set. It's all of the x values. So we have a 2, we have a 7, we have a negative 4, and we have smiley face. And there's our domain, written in set notation here. We could get a whole lot into different things about set theory and what makes a set and how we write it in, but we don't need to do that for our purposes here in Algebra 1. Now similarly, the range is just going to be the set of all the y values. Here we go, 3, 6, 2, and rhombus. 3, 6, 2, and rhombus. 3, 6, 2, and rhombus. So the range for this example, given any of these representations, is pretty easy. We just write down all of the y values in a set, and that's the range. And there we go. Pretty simple, right? Okay, well, those are the easy ones. Let's look at an example for a graph. Actually, a couple of examples. Oh, wonderful.
Esmeralda, bueno, please come to the main office. Esmeralda, bueno, please to the main office.
So now looking at a couple of graphs, this top one, well, the function is going to be all of the ordered pairs on this line segment here. Now we need to notice this here too, that this point, 4, 1, we have an open circle, which says that that point is not in the function. We have all the points right up to that point, but not this specific point itself. The filled in circle says that yes, we are including that point. So in this case, the domain is going to be the set of all the x coordinates. So these x's, we can see the leftmost x coordinate is going to be this negative 3. the rightmost x-coordinate is going to be 4. So we can write this in a couple of different ways. If we want to use set notation, it's going to be the set of x. Now we're going to use a vertical line here. And the vertical line just means such that. So we want the set of x such that, and now we can put in a little condition on it. And so we want the x's to be bigger than -3, but inclusive, because x can be actually -3 here for this specific point. But now we want the x's to be strictly less than 4. So this is our set notation for an infinite set like this. Certainly we couldn't write down all of the x values for all these points because there's infinitely many. But we can specify the interval that the x's are in. They're in between -3 and 4, including -3. That's why we have less than or equal to, but strictly less than 4, because we're not including this point in the function. Now we could write this a little bit differently, and with what's called interval notation. And interval notation is going to look like this. We're going to use a bracket here. -3 is the leftmost value for our x's, and 4 is the rightmost value. But for 4, we're going to use a parentheses. So what this interval notation is saying is that we want all points in between -3 and 4. The bracket says we are including -3. The parentheses says we are not including the 4. But we can get all the way up to as close as we want to 4 as we want, but just not the exact point 4 itself. And this is what we call interval notation. We'll get some practice with this in class. Okay. Now the range for this particular graph is going to be the set of all the y values. And so the y's now, the lowest y value is the -2 at this point. The highest one is the 1 for this point. But we're not going to include that one because this 0.41 is not actually in the function. So the range is going to consist of the set of y's such that -2 is less than or equal to y, and y is strictly less than 1. Or in interval notation, we would use an interval from -2 to 1, the bracket saying, yes, we do want to include the y value of -2. The parentheses says we don't want to include the y value of 1. Okay. Now, this next example, we've got a nice parabola here. So the domain for this one, we're going to have the set of all x values. Now, even though it looks like it keeps getting steeper and steeper and steeper, this parabola is not ever going to actually turn back on itself or just get vertical. It's going to still keep going down, but it's also going to be going out this way as well as to the right this way. And so for these types of graphs that we're seeing, and that's usually what we're going to be dealing with, the domain most commonly is going to be the set of all real numbers. So any x, the x can be any real number you want, anywhere along the real number line. Now the range, the y's, well, we see that the highest point we have is this point 3, 4. That's what we call the vertex of the parabola. So the y's are going to have a maximum value of 4, but then notice all the points here, the y's just keep getting smaller and smaller and smaller and keep going all the way down negatively forever. So if we want to talk about the y's here, the y's are going to be going, the biggest value is 4. So that's the right side of, range. The rightmost point, if we're looking at the number line, or the topmost one for the y's. 4 is the biggest value. The smallest value, well, there isn't one, because it keeps going on forever like this. So the y's are shooting off to -infinity. But -infinity is not an actual number, so we certainly can't include that in our interval. So we use a parentheses there. Or, this would be interval notation, we could also write the set of y's such that y is less than or equal to 4. Okay. Now lastly, if we're given an equation like this, say f of x is equal to x squared plus 4, this is a little bit more difficult. Without a visual of a graph, it's tough to see what the domain and range are going to be. But here's the big thing. When we're identifying the domain from an equation, for our purposes right now, the only thing we have to worry about is dividing by 0 and taking the square root of a negative number. We can't do that, either of those things. They're commonly said they're undefined. Well, not completely, but for our purposes, yeah, you can't divide by 0 and you can't take the square root of a negative number. But so here, since nothing is being square rooted and we're not dividing by x in any way, it doesn't matter. We're okay. We can put in any value here for x and you can square it and add 4 to it and you're not going to run into any problems. So, like most of the functions we're going to be dealing with this year, the domain is still going to be all real numbers. Now the range, that's going to be a little bit more difficult to see. And so if you really want to find out what the range is, the best bet would be to grab your handy dandy calculator and make a graph of this thing. So we'll plug it in, y equals x squared plus 4. And we'll graph this thing. Oh, wouldn't you know it, there's our nice parabola, as all quadratics do. And we see the smallest value is there at 4. So the range here, if we wanted to use set notation, is the set of y's such that y is greater than or equal to 4. Or, if we want to use interval notation, the smallest value for y is 4, and the biggest value for y, well, this parabola is just going to keep on going up and up and up forever, so the biggest value is going to be infinity. But since infinity is not an actual number, we can't include that in the interval, so we use a parentheses to show that's the actual number. Infinity, well, the thing that's not a number, which we call infinity, is not actually in the interval. Okay, so these two things are referring to the exact same set. Okay, well that's about it for domain and range. We'll get some more practice on identifying these things in class. Thanks for watching.